A negatively charged object has excess electrons. If the object has 2 times 10 to the 10th excess electrons, what is the charge of the object? So you're given the number of excess electrons and then the charge of 1 electron. For you to be able to get the charge of the object, you just have to multiply the number of excess electrons and the charge of 1 electron. So doing such, it will give you an answer of negative 3.2 times 10 to negative 9 Coulomb. For the next problem, we have how many protons are present if the charge of the object is 1.6 times 10 to negative 13 Coulomb. So here are the given. We have the charge of the object, and then the charge of 1 electron is equivalent to negative 1.6 times 10 to negative 19 Coulomb. For the solution, for us to be able to get the number of excess protons, we have to divide the charge of the object divided by the charge of 1 proton. Substituting the given, we have 1.6 times 10 to negative 13 divided by 1.6 times 10 to negative 19. We will have 10 to the 6 protons. So that's how you solve for the number of protons. Next problem, the electron and proton of hydrogen are separated on the average by a distance of about 5.3 times 10 to negative 11 meters. Find the magnitudes of the electrostatic force. So we're given the charge of proton equals 1.6 times 10 to negative 19 Coulomb. Then the charge of the electron is equivalent to negative 1.6 times 10 to negative 19. The separation distance is 5.3 times 10 to negative 11 meter. And then we have a constant which is 9 times 10 to the 9 Newton meter squared per Coulomb squared. For us to be able to get the electrostatic force, we have the formula electrostatic force equals the constant Q1 Q2 over D squared. Substituting the constant 9 times 10 to the 9 times the charge of proton 1.6 times 10 to negative 19 times the charge of the electron 1.6 times 10 to negative 19 divided by the separation distance, which should be in meter. We have 5.3 times 10 to negative 11 meter. You will get an answer of negative 4.35 times 10 to negative 18 newtons. So this is negative because the force in between them is actually a force of attraction, since we have a positive and negative charge. For the next item, we have two charges feel a repulsive force of 96 newtons. What is the force if the separation distance R or D is quadrupled? So that is 4 times the distance. So we now have the two electrostatic forces. We have KQ1 Q2 over D1 squared. Then the other one is KQ1 Q2 over D2 squared. Now the term KQ1 Q2 are the same. So therefore we can now equate FE1 D1 squared equals FE2 D2 squared. Deriving it further, we can now get the electrostatic force, the second electrostatic force. We have now 96 times D squared over 4D squared, since it was mentioned that it is quadrupled. Solving it further, we will have Fe2 as 6 newtons. Now see that since the distance is quadrupled, the electrostatic force has decreased. to 6 newtons. It became 1/16 of the original electrostatic force. For the next item, we have the following 3 charges are arranged. Okay, look at your module. Now determine the net force acting on the charge on the far right, or Q3. So here are the given. In order for us to be able to solve this one, since we are looking for the net force, we have to solve first for the force exerted by 1 on 3, and then afterwards, let's solve for the force exerted by 2 on 3, and then we will sum them up, depending on the direction of the force. So first solution, we have here, okay, for force exerted by 1 on 3, we have K, Q1, Q2. Let's use the absolute value, then the distance between 1 and 3. The force now is equal to 9 times 10 to the 9 Newton meter squared per Coulomb squared, times the absolute value of negative 2.3 times 10 to negative 7. Then we have multiplied by 3.4 times 10 to negative 7, which is the charge of Q3, then divided by their separation distance, equivalent to 3.3 meters squared. Then final answer for the force exerted by 1 on 3 is equal to 6.46 times 10 to negative 5 newtons. Solving for the next force, we now have the force exerted by charge 2 on charge 3. So we have K, Q2, Q3 divided by the distance between them squared. Substituting the given, we now have 9 times 10 to the 9 Newton meter squared per Coulomb squared, times 1.6 times 10 to negative 7, times 3.4 times 10 to negative 7, then divided by 1.5 meters squared. So the force exerted by 2 on 3 is equivalent to 2.18 times 10 to negative 4 newtons. Okay, looking at the illustration, you can see that the force exerted by Q1 on Q3 is actually an attractive force. So that is to your left. And then the force exerted by Q2 on Q3 is a repulsive force. So that is towards right. So we will assign the force exerted by Q1 as negative, and then the force exerted by Q3 as positive. Okay, just interchange the sign. Let's now have negative 6.46 times 10 to negative 5 newtons plus 2.18 times 10 to negative 4 newtons. So the answer should have been positive 1.53 times 10 to negative 4 newtons. So that means that the charge will actually move to the right.